All right, so here we go. So we are starting with 4.3, like we mentioned already. Sorry, I had a sneeze, didn't want to come out. All right, so 4.3, modeling linear trends. So I don't know if you remember last thing. One of the things I told you that we use easycalculation.com or an app for is the regression line. We talked about correlation coefficient last class. Today we're talking about the regression line. So it's a tool for making predictions about future observed values. It provides a useful way of summarizing a linear relationship. So we talk about the equation of a line just in general. You have y equal to mx plus b. Some of you may remember that from algebra. M is your slope. That's what's sitting in front of x. That's what's attached to x. And then b, the other number, is your y-intercept. Try not to scroll up too far. And so some of this stuff, just give it to you just in case Math Lab asks you about it. Says for stats, they normally use a plus bx. Same type of relationship though. What's sitting in front of x is going to be your slope. The other number is your y-intercept.
Yes, quick question. Is this the beginning of the notes? I came in late.
It was a little bit up top. Before we leave, I can scroll up and I'll let you get that.
Okay, thank you.
Yeah. So just remind me before we close out. I can get that to you.
Okay.
All right. So once again, what's sitting in front of x, what's attached to x is going to be our slope. And then the other number is our y-intercept. All right. Anybody still on the purple?
Oh, hold on, go back up a little bit, please. I'm sorry. That's fine.
Okay. So just letting you get started on writing that. As soon as you scroll up, then we'll, look at the whole thing. But let me see. It's one. Let me try to write some of this better. Since somebody attacked my handwriting last class.
I mean, like.
I just said you went into the wrong field. You just needed to go in the medical field.
That's what I was getting ready to say. He definitely has a doctor's prescription handwriting.
I wish I was making doctor prescriptions money. I'll tell you that. Oh, good. So we have a college instructor with far too many books on his shelf is wondering whether he has room for one more. He has 20 millimeters of space left on his shelf. He can tell from the online bookstore. Is anybody holding on to purple? All right, so everybody good with the purple? So he can tell from the online bookstore that he wants, I didn't read it. Tell from the online bookstore that the book he wants has 598 pages. The regression line is, let me erase that circle because you don't need that right yet. So they give us predicted width is equal to 6.22 plus 0.366 pages. So this is how my math lab gives you the regression line in this instance. So I'm going to show you what that means in a second, but I'll let you guys write it out first. All right, so if you remember what we had when we were talking about just an equation, we had y and x involved. Right now, and when they give you the equation in this form, they're letting predicted width to represent y, and your pages to represent x in those places. So that's why I just circled that would actually be your y, and then pages right here. Pages right here would actually be your x. So if we had to put them in that same type of context. So the question is, will the book fit on his shelf? All right, can I scroll up? So I wrote some statements about the regression line. So we understand where it comes from. The regression line is based on previous observations. And because of those previous observations, you are able to make a prediction on future observations. So what ended up happening, he had a whole bunch of books on the shelf. He used those books and the information from those books. In other words, he took the pages and compared the width for each one of those books, compared, pages to width, and he got this equation. And we'll talk about how we'll be able to calculate that equation in a few. So he got this equation. Now what we can do is take the pages from the book that we know that we want to purchase, plug it into this equation and predict how thick the book would be. And so that's what the regression line is used for. I'll take that black blue. So that's what we're going to do. We're going to take 598 and plug it in because it's 598 pages, plug it into the equation, and it's going to give us a predicted width as to how thick we think the book will end up being if it's 598 pages. All right, of course, let me know if I'm scrolling up too far. So plug 598 in, 0.366 times 598, no order of operations, do multiplication first. It gives us 21.8868, add that to 6.22, and that'll give us the predicted width of 28.1068 millimeters. All right, any questions so far? All right. So now you can come to your conclusion. You go back to the page, not the page, to the word problem. We only had 20 millimeters left on the shelf. So this book should not be able to fit on the shelf. We have 28. Someone said something in chat. Oh. So 28 is the answer. of how thick we think the book should be is not even close to the 20 that we have left. So it shouldn't be able to fit on the shelf. All right, everybody okay with that first example?
Just 1 second, please.
One
Mhm.
second.
Yep, not a problem.
How did you get, so when you went over the predictive width, equals 6.22 plus 0.366,
Mhm.
where did those numbers come from?
He did that. They gave it to us.
Oh, that was given. Okay.
Yeah,
Okay.
that was given right here.
Oh, here. Okay. Thanks.
Not a problem.
Is that where the 21.8868 is too? Because I didn't see that up there.
Yeah,
No.
multiply these two numbers, and that gave you that.
Got it. Brackets didn't register that.
Okay, yeah, not a problem. Yeah, so yeah, order of operations, do the multiplication first, and then add it to the 6.22. How we looking? Can we scroll up? We good? Hold on a second. All right, so when we have our data, this is how we will be able to find our regression line. Is everybody done with the red? Everybody done? Okay. Let me put a multiplication symbol right here.
For the slope, that is R 5y over 5x.
No, that's R S sub Y over S sub X. That's actually an S with a smaller Y.
I got you.
Yep. So to find a regression line, to find the slope, which is B for us, like you just mentioned, that's R times S sub Y over S sub X. To find the intercept, we have Y bar minus B times X bar. So notice you have to find B first before you find A. And then once you find both of those, then you actually have your regression line, which is Y hat equal to A plus B X. So those letters, what does that mean? R, we talked about R last class, that's your correlation coefficient. X bar is going to be the average of your X values. S sub X is the standard deviation of your X values. Y bar is the average or the mean of your Y values. S sub Y is the standard deviation of your Y values. I think I got one more down there. Okay, yeah. And then Y hat is actually our predicted Y.
Can you read those again? Because I'm trying to read your writing. Yeah, you've like abbreviated it, so I'm sorry, I'm trying to keep up.
Yep, correlation coefficient. The mean of, well, we talked about the explanatory variable, so I was just calling it X, but it's your explanatory variable. That's
Is that
what
an R that equals the correlation coefficient or a V?
R. Yep.
Okay.
Yep. I don't know if that even helped. That's how I write my R's.
It's more like a
could-
B.
Somebody else
I
say
was
something
gonna
else?
say, I was gonna say, like, when you have some free time, like we can give you a class in like handwriting. If
I don't
you
want
wouldn't
it.
mind.
I don't want it. I don't want your class. Then Y bar. And so I did SD right here, standard deviation. Then Y bar is the mean of your response variable. This standard deviation of your response variable. And then predicted Y. So as you guys are finished writing that, they can give you the data value in one of two ways. This is one of them, wherein they give you these pieces and you plug it into the formula. The other is that they just give you a data set, and then you would just go to easycalculation.com and type in the data values like we did last class. So they can give you the information either this way, or they just give you all of the data values and you plug them in.
What does Y hat say again?
Predicted Y.
Thank you.
Where it says Y minus bar, and then it says Y bar equals the mean of what?
Response variable.
Response variable. Okay, thanks.
See, I'm not even going to tell y'all who give me confidence. She said
open
in a direct
invitation.
message that she can understand my handwriting because she writes
Oh,
the same.
Yeah, like some of it we can understand, but I know that it's just like charting on a patient. It's like, I know what I'm trying to say, but it doesn't come out the way that what I'm trying to say.
Right.
I just suck with abbreviations, to be honest.
But see, the funny thing about abbreviations that you make up, you're the only one who knows that you what you're doing. So I understand that completely. It's all good.
Okay, one more time. The EXP stands for what again?
Explanatory variable. Basically, your explanatory variable are your X values. Your response variable are going to be your Y values. All right, let's see what's next. Okay, we got an actual example. So we have an example that you'll see how we plug those in and come up with our regression line.
Is it the Y minus hat?
It's just Y dash hat, it's just Y hat. But yep, Y hat.
Thank
All right, can I scroll up a little? Everybody good? Everybody done with black or no? All right, so now this was a long problem. Yeah, I still shortened it up some though. That's why I got those little dots right there, just letting you know what's more in between there. But I just wrote down what we need, what we needed. So we have a college in the US used SAT scores to help decide which applicants to admit. To determine whether SAT was useful in predicting success, the college examined the relationship between SAT scores and first-year GPAs of admitted students. So I'll pause right there for those who are writing it. Then I'll scroll up in a second. Back scroll up a little bit. So it says the average math SAT score of the sample was 649.5 with standard deviation. SD, I use a standard deviation, 66.3. Then we have the average GPA was 2.63 with standard deviation of 0.58. And the correlation between them was 0.19. All right, good. Everybody up to the dots. So with A, it says find the equation of the regression line. So EQ is equation, REG is regression line. And then it even told us, note that your SAT scores was X and your GPA average was Y. Or GPA is already average in A. Then it says use the equation to find a predicted GPA of a person with the SAT score of 650. All right. All right, can I scroll up past the green? All right, let's go there. Stop right there for a second. So whenever you're doing the word problem, I always suggest that you write down all of your given pieces of information first. Write down what value is assigned to what symbol and so on. So if you look in A, they tell us that X, our X variable, our explanatory variable is going to be assigned to the SATs. The GPA is going to be Y. Whatever you're trying to predict is always your Y. So notice in B, it says use the equation to find the predicted GPA. So that lets you know that that's your Y, your response variables. So we're using X, we're using your explanatory variable, in this case, the SATs, to be able to explain or to predict what the GPAs of a first year college would be, first year college student will be. So that's what we're trying to do here. So that's why your GPAs, I mean, your SATs are X, GPAs are Y. All right, and then he tells us our correlation was 0.19. So correlation is R. Questions on any of the word association with the symbols? Is everybody okay? All right. So if that's the case, you want to find B first. So the formula for B was R times standard deviation of your Y values over the standard deviation of your X. So this was the substitution here. 0.19 times 0.58 divided by 66.3. That gives us 0.001697. Always pay attention to my math lab and see how many decimal values they want you to go out. I always go out 4 or 5, but since it's had 2 zeros in front, this time I went out 6. But you know, always pay attention to math lab and they'll let you know how many decimals they want in the answer. All right. So then to find A, you do y bar minus b times x bar. So we took the average from your y, which is 2.63, minus b, which is 0.001697, and multiplied it times 64, let's say 64, 649.5. And that gives us 1.53. All right. Any problems with what we've done up to this point? Make sure we're okay. Once again, they gave us the values and all we did was plug them into the formulas. So this will be our regression line.
Is that 649 or 699?
649.5. Mhm. So this is our regression line, or if you remember how we saw our regression line the first time, we had words in place of the variables. So since they told you that X represented your SAT, Y represented your GPAs, they could ask you to write it this way. You know, if that's the case, then what they would do is have the boxes and you would just type in the numbers, where those boxes would be. You know, so just showing you the two different ways that you could see the regression line. All right. Hold on 1 second. I thought that says A. Oh, yeah, I must have put A by mistake twice. Yeah, it should be B. All right, are you ready to go to B? So B, it says that use the equation to find the predicted GPA of a person that has the SAT score of 650. So that means we're going to take 650, plug it in for X, and find the predicted GPA of somebody who has that score. That's what we did right here. Mhm. Questions. Let me see if they give you, this is 4-3. All right, so the next thing we're doing is distinguishing between X and Y. I'm going to give you different characteristics between the two. Thought I already gave it to you, may not have because of this order, but just give it to you again if I didn't, so it's all good. So choosing, everybody wrote down this title yet before I go to the next page? And of course, this is a note for me, it's not for you guys. All right. All right, so right here, just showing you the differences between the explanatory variable and the response variable. So your explanatory variable, like we were talking about in the last example, will explain the value of your response variable. and then your response variable pretty much
Give us
responds
that
to it.
already.
Hmm?
You gave us that
I
last
did
class.
give you this. Okay.
Yeah.
Okay. I thought I gave it to you already. I
You
thought we
did.
already talked about it. So yeah. So I won't waste your time explaining
You were
this
just
again.
making sure we were paying attention, that's all.
Yeah, that's all. That's what I
I
always try
know,
to do.
listen, I know,
Try to make sure everybody's on
know.
their toes.
I know.
Thank you. So yeah, so that's it for that then. Let me check one thing though. I want to make sure that they didn't have another example that I want to make sure you guys see out of 4-3. I might be thinking about my 245 class again though. All right, cool. All right. Yep, must be thinking about 245. Okay,
So
let's go to
the little red note is for you?
Yes. Yeah, I was just telling myself to go to 245 in the notes. So yeah. I don't know if I posted the second test yet for you guys, but we really haven't covered everything on the second test until today, after we do 4.4, then that's the end of, that will be all of the content for the second test. Yeah. Okay, so 4.4. I don't believe there much calculation in this one. It's just talking about, just that last coordination determination. Okay, so evaluating the linear model, just pitfalls to avoid. So a lot of the stuff in this section, you're talking about just different things you want to make sure you're careful of. Don't fit linear models into non-linear associations. So the regression line is only for linear models. So, we go back to, remember we had, certain ones that had an arc. As far as your scatter plots, this regression line wouldn't fit for that. It only fit for those who are fit into, a linear pattern. So the regression line is not going to be able to predict, arcs or waves. We talked about it before. Correlation is not causation. Just because you find a pattern or correlation between your, let's go back to the SATs and the GPA, that don't mean that there's a causation there. Remember we talked about the liquor store. We take the liquor store out, that doesn't mean all crime is going to evaporate. Beware of outliers. Outliers will affect your regression line because it's based on means. Remember, your means are affected by outliers. We talked about that. So we do need to be aware of outliers. And I don't know, wrote that real small like that, expecting y'all to, let's see if that'll help. So regression lines of aggregated data, in other words, groups of data. It can be used for groups of data. But then, just saying, watch it. And then here, don't extrapolate. Don't make predictions beyond the range of data. So one example they used in that case is that, let's say if you have the growth spurt or the growth of young people, let's say 6 to 12, but you can't use that same data on teenagers to young adults because they go through growth spurts, and that's probably another set of data. And so you can't take that information and say, okay, I can use this on teenagers now to predict their heights because of their type of growth and growth spurts and everything. So in other words, you can't just make predictions beyond the range of the data that you have. All right, so they're just pitfalls to avoid. So if my math lab asks you, which one of these are pitfalls to avoid or something along those lines, at least you'll have them to be able to answer the question.
What's the last word in the one that says correlation is not
Causation.
causation? Thank you.
Causation, yep. Mhm.
At the bottom where it says don't make predictions beyond the, what else does it say? Because Zoom's in the way. I can't see the last little
Oh,
bit.
sorry. Range of data.
Thank you.
Not a problem. All right, let me know when I scroll up. Oh, got to go to my other set of notes. Yeah, and then we'll be done. Okay. So we have one more thing to talk about, the coefficient of determination. And then that'll be it for 4.4. All right, are we good to go to the next page? Somebody still copying? All right. All right, so the coefficient of determination. It measures the proportion of total variation in the response variable that is explained by the regression line. All right, it basically tells how reliable the regression line is. It is actually the correlation coefficient squared. So now it's just one more step past something you've already calculated. So you just square the correlation coefficient. It is denoted by capital R squared. It is between 0 and 1 inclusive. It's still 4.4. So 4.4 is our last section. 4.4 is the last section. So we're just finishing off 4.4. At least I don't think so. 4.5. Now you got me looking. Not a problem. So if R squared, the regression line has no explanatory value. If R squared is equal to 0, then if R squared is equal to 1, the regression line explains 100% of the variation in the response variable.
Can you slide up just a little bit? I was just getting that right there. That's good. Thank you.
Mm-hmm. All right, scrolling up some. All right, are we good to scroll up? All right, so we want to determine and interpret the coefficient of determination for the club head speed versus the distance. We're talking about a golfer here swinging his club and how far the ball travels. So right down with black. All right. So now, if I'm not mistaken, we found this on last class, the correlation coefficient. Is everybody copying? Let me wait for everybody to finish copying, just so I can, y'all can confirm whether we did what I think we did.
I'm in the red, Professor.
Okay, cool. All right, so everybody at the red, before I switch screens, you don't have to copy anything right now. When I switch screens, I just want to make sure that we did what I think we did. We're here down. So if I'm not mistaken, we had this group of information right here. And I went to easycalculation.com, put those data values in, and we got that value. So we did do that here?
We did.
Okay, all right. Just make sure I got the right class, man. I got too many classes going on. If y'all didn't know, I teach at 3 different schools, so I'm all over the place. One is in North Carolina, actually. So yeah, I'm all over the place. Anyway, so just got to make sure I'm talking to the right group of people. So that's how we got that R, 0.939. So then we find the coefficient of determination by just squaring that. So no extra, no extra app on that. You can just 0.939 squared. That gives us 0.882. If they ask you, what is it in percentage, you just move your decimal 2 places to the right, give you 88.2%. And then from there, what does that mean? So that means 88.2% of the variation in distance is explained by the regression line. Subtracting that from 100, 11.8% of the variation is explained by other factors. So in other words, we're not perfect. Maybe you swung, twisted your hip more one time that you didn't the other time. You swinging a golf club, or wind could have played a role in why the ball didn't travel as far as it did one time, versus another time. Just other factors come into play, and that's what that 11.8%, gives leeway to. And so that just means that the regression line has an 88.2% reliability. So 88.2% of the time, your prediction will be correct. But of course, there's a chance that it may not. Remember, it's just a prediction based on the observations that you've already had. And that's your coefficient of determination. Gotta reposition that. So any questions on anything? All right, that should be straight. So I was putting, making that test 2 available for you.
What's that last word on that last bullet point?
All right, let me get right to it. Reliability, talking about this one right here.
Yep, thank you.
Yep. Regression line has
Yep.
a 88.2% reliability.
Yeah, that could be mistaken as like a half a B or possibly a LELIAB.
I just couldn't see it because of Zoom.
Oh, you got, so there's a Zoom, there's something in Zoom that's blocking that down here or something?
Yeah, it's the mute, start video, participants, chat, that thing.
Oh, gotcha. Okay. Yeah, because once I share my screen, that stuff goes to the top. I think I can put it to the bottom. I wonder, can you guys move it too? But anyway, I think I can't move that to a screen, like drag it, put it on the bottom. But yeah, okay. So that's it for us as far as new material in chapter 4. Don't have to push anything, don't have to rush. So I'm not going to necessarily jump into a new section today. Let's see something. So we got 5, 6, 7, 8. Yeah, we should be good. Yep, we should be good. So yeah, we're in a good place, real good place. Questions on anything that we've done up to this point?
I'm still like a little lost about the question you put up there about the SAT scores and GPAs.
Okay. Let's go back right here. Okay.
I think I was so busy copying down everything. I didn't really
Mhm.
understand how you got everything.
Okay. So going here, these values, we didn't get them, they gave them. So they gave them to us in here.
Okay.
So that's where we got those values. You just have to make sure that you give them to the right letters. So they tell us that X is our SAT, Y is our GPA. So when they say the average SAT, then that means your average X. And standard deviation of the SAT, standard deviation of X, correlation was 0.19. And then they said that the average GPA was 2.63. That's why that's Y bar. And then the standard deviation of the GPA was 0.58. So that's where we got that from. We got that from the problem. So we didn't really do any work for that. So cool with that part?
Yeah.
Okay. So then from there, we're taking each one of these pieces and plugging them into the formula that we got from here. So we need B and we need A in order to have our regression line, because that's A plus BX.
Okay.
And so from there, we're plugging them in. And for the most part, use your calculator unless you just got it like that. So yeah, so that's why we have R, which is 0.19 times S sub Y over S sub X. And like I said, that came from here. And then throw that in your calculator, and that's how we got that value of 0.00169. And then to get A is Y
So you just do 0.58 divided by 66.3.
And then times it by that 0.19.
Times by, okay.
And then to find A, we have to do Y bar minus B times X bar. So don't forget, you do have to find B first because B is a part of the formula of A.
Okay.
And then, so Y bar. And then, so that's Y bar minus B, which is what we just found, times X bar. And throw that in the calculator, you get 1.53. And going back to your regression line, remember that your right here, your regression line is A plus BX. Oh no, give me that back. There we go. So going back here, you know, this was A, this was B, so that's A plus BX. And once again, as I rounded to 0.0017, that's probably because that's what my math lab asked for, and, you know, versus that, I just rounded that. But always pay attention to how many decimal places my math lab is asking you for. And then also they could say, you know, replace this with the words. You know, they already told us the X was the SAT. And then remember, this is always going to be predicted, whatever Y is. So predicted GPA. They told us the Y was GPA. So you can write it in either one of these forms. You know, my math lab could ask you for the answer in either one of those forms. All right. So is that okay? Just make sure you're good. All right. All right, so then from there, B was just asking us, or it told us to use the equation to find the predicted GPA for somebody who has an SAT score of 650. All that means is you take 650 and plug it into the equation that we just found for SAT or for X and calculate, and that will give us that predicted GPA.
Okay.
Mhm. And once again, 650, they gave us that, they told us, you know, they wanted us to plug in 650.
Okay.
Mhm. Yeah, and that was it for that problem.
Thank you.
Yeah, not a problem. Anything else, anybody else? Some things may not, you know, some questions may not come up until you actually ask, you know, get in there and start doing some work. So I understand that as well. So next class, I will open up the floor for questions first. You know, that will be the thing. Making sure we are good from chapters 1 up to 4. And if you have questions, we'll you know, attack them. If not, then we'll get into chapter 5. All right. Anything else? Anybody else before we close?
I needed that first part, whatever I missed,
Okay. Yeah.
and that was it.
All right. I think we 4.3 right there. All right. So let me know when you want me to scroll up or whatever. All right. So if you guys are good, I'm good. I think you guys have enough work to do. Don't have to do anything else extra right now. Like I said, next class, we will get into chapter 5 and answer whatever other questions you guys have. Other than that, have a great week. Be safe, and I'll see you on Tuesday.
Thank you.
Thank you. Have a good
Thank
one.
you.
Take care.
Thank you.
Thank you.
Thank you. Have a
Thank
good one.
you.
Take care.
Peace.
Yes, sir. Take care, man.
There.
Okay, so just a question before, was there anything before this?
No, we started with 4.3.
Okay.
Miss Merkel, were you trying to say something? I didn't know if you were.
Oh, sorry. No, sorry. No, I'm good. I'm good. I was just making sure nobody else was asking any questions I could go over.
Oh, okay. I thought you
I'm
were hitting
good.
buttons and stuff and it won't work, and you just like I know.
No, sorry. No, my girlfriend just came in and told me like her grandpa just got admitted to the ER. So I'm like
Oh
a little
no.
distracted right
I can
now.
imagine. Oh
Sorry.
man. No, you're all good. You're all good.
Thank you though.
Not a problem. Take care.
You too. Bye-bye.
Bye.
I'm gonna just actually take a screenshot of this so I don't hold up your time.
Oh, okay. Okay. All right. Not a problem.
Okay,
Let me
you can
know.
go. You can slide up.
Okay.
Yeah, there we go. Okay.
All right. I don't know if you got this or not.
I think I started right there.
Mhm.
Yeah, I got that part on down. So
Okay.
I just did those two.
Okay, cool.
All righty. Well, thank you.
Not a problem. Not a problem. You have a good one.
You too. Bye-bye.
Bye. Anybody else before I close out? Anybody? All right. You guys have a good one. I will see you next class.